Hi. There were a lot of questions about um, the sparkling orange juice problem. So I wanted to share a little bit about how I might think about this problem. One of the things that people found challenging was that, like, figuring out how to use the double number line tool when you have two different situations, but only one double number line. And this is what I would probably do. These are all screenshots, and I put them into OneNote so I can write all over them. But what I did was I made one double number line for Noah's mix, um, and I set up the settings. So the bottom, remember, A is the bottom line. So soda liters 5, and then the B is the top line. So that's orange juice, which is in liters, and 4, and it's 5 and 4 because he uses 4 liters of orange juice with 5 liters of soda water. And then because it's needs to go to 5, there's one major tick, and then the minor ticks are 4 because that takes us 1, 2, 3, 4, 5. And then I did the same thing with Lynn's, only I changed her numbers. So her increments are 4 and 3, and her minor ticks, because she's going 4 liters of soda, I need 1, 2, 3 spaces there. And obviously, because if you're working in Desmos, you can't have everything that you're looking at like this. But it's pretty easy to switch, to use this tool to change what your double number line looks. So yeah, okay. Let us zoom in a little bit. Cool. So Lynn makes sparkling orange juice by mixing 3 liters of orange juice with 4 liters of soda water. All right. And how do the mixtures compare in taste? And then the other thing they're going to ask is, okay, so if we look to see how much orange juice per 1 liter of soda, for Noah, here's how I might think about it. I know that soda is going by ones, because I set it up to go by ones. I, as a mathematician, am in charge of my life, so that's what I did. And then the question is, how much orange juice do I need to go with 1 liter of soda water so that it tastes right? And so what I'm doing here, you can use the multiplication and division relationships in double number lines. If I'm going from 5 down to 1, I'm dividing by 5. So I'm essentially saying 5 divided by 5, this 5, equals 1. So to go from 4 down to that number, I'm still going to divide by 5. And then I get 4 divided by 5. A fraction, a division problem, you can write that as a fraction. 4 divided by 5 is 4/5. So you could write 4/5. You could also, 4/5 is the same thing as 8/10, which is 8/10 as a decimal. You could do either way if you want to. So for Noah's mix, for 1 liter of soda, Noah uses 4/5 or 8/10 of a liter of orange juice. In fact, maybe what I'll do, okay, I'm going to do Lynn's next, and then we'll compare them in the ratio table. For Lynn's mix, it's the same idea, but with a different scale. So Lynn is going 1, 2, 3, and 4. So what I'm doing for Lynn is I'm starting with this 4. I'm going to 1. So I need to divide by 4. So 4 divided by 4 is 1. So I'm going to do the same thing here. I'm looking for that value. Divided by 4. So 3 liters of orange juice divided into 4 batches gives me 3/4 of a batch. And you can double check that makes sense. 3/4 plus 3/4 is 1.5. 1.5 plus 3/4 is 2 1/4. And 2 1/4 plus 3/4 is 3. So that is correct. Okay. So then if I were, okay. So if I'm going to do person, liters of orange juice, water, Noah, Lynn, and it's 1 liter of water. I think Desmos asked you to do this. You can see that Noah uses 4/5 of a liter of orange juice for 1 liter of water, and Lynn uses 3/4, which is 0.75. So you can see here, Noah uses more orange juice for 1 liter of water. So Noah is going to taste more orangey. Okay. And then I think the other thing that they asked us to do this table the other way. So instead of doing, yeah, I'm running out of space. Let's do this. So instead of doing, we're still doing person. And then they switched it. So they want to know how much water does each person use for 1 liter of orange juice. So we'll do the soda in liters, orange juice in liters. And I think for this, because of space, I'll show you guys another strategy. So this is a different strategy you could use. Because it's nice to know lots of different strategies. All right, so Noah and Lynn. And Noah's ratio is 4:5. The ratio is OJ to soda. His is 4:5, and Lynn's is 3:4. Okay. So if we want to know, if I want to know for 1 liter of orange juice, I can set up a rate. And a rate looks like this. And I can set up a rate either way. I can set up a rate where orange juice is on top and soda's on the bottom. Or I can set up a rate where soda's on top and orange juice is on the bottom. Those are both rates. They give us they represent the same relationship, but they give us a little bit of different information. So you got to pick the one that is most helpful in your situation. For us, because I want to take the soda down to 1, I'm going to use this one. Okay. So for Noah, what does he do? Noah, he has 5 liters of soda for 4 liters of orange juice. Okay. And I want to get that down to 1 liter of orange juice. And if you notice, this is starting to look a little bit like a fraction. That is because it's supposed to. If I wanted to reduce that down to like over 1, I need to go 4 divided by 4 gives me 1 liter of orange juice. So 5 liters of soda divided by 4 is going to give me 5/4 liters of soda. You can express this value in lots of different ways. You can call it 1 1/4 liter of soda. You could also call it 1.25 liters of soda. All of those mean the same thing. So I'm going to keep with my fractions. Uses 1 1/4 liter of, I actually don't need the units there because it's in my table. Okay. And then for Lynn, we're going to do the same idea. she does 4 liters of soda for every 3 liters of orange juice. In this case, I'm going to divide those both down. I want to get from 3 to 1 liter of orange juice. To get from 3 to 1, I need to divide by 3. So I'm going to do the top, same thing. Oops, except I wrote the wrong number. 4 divided by 3 is 4/3. 4 divided by 3 liters of soda. And you can write that as 1 1/3 liters of soda. You could write that as 1.333. It repeats, thirds repeat forever. You can call it close to 1.33 liters of soda. This right here is one of the reasons why I prefer fractions, because fractions never have, they never go repeating on me. So 1 1/3. Okay, and you can see here that Noah uses less soda per 1 liter of orange juice. So if he uses less soda per 1 liter of orange juice, it tastes less orangey and less soda-y and more orangey. Lynn uses more soda, a little bit more soda per 1 liter of orange juice. So hers tastes more soda-y and less orangey. All right. I've shown you guys 2 strategies. The first strategy is we can use those double number lines, but we probably need to make one for Noah and then one for Lynn. The benefit of doing this in Desmos is you can just change a few little numbers, like change those, change the minor ticks, done, done, done. You can see what you need. The other strategy I showed you is you could write a rate and then divide it down to find a rate per 1. Yeah, cool. All right. I hope this was helpful. I don't know how to stop.